Okay, here we go with our second question. So our second question is, where are potential discontinuities? So we know what our three conditions need to be, so our instructions might be, in terms of a problem, to discuss the continuity of a function. If we are lucky, our directions say, discuss the continuity of this function at x equals 5, and they tell you what point to look at. But in other cases, they might not specify what point to look at, and so if we're given a function, we aren't going to proceed to plug in every number we can imagine. That's not even possible, right? Plug in 1, plug in 2, plug in 3, plug in -7. You'll never stop plugging in numbers. And so what we are doing through the second question is we're going to analyze and we're going to understand where we want to look to identify potential discontinuities in case they don't specify. Okay, and so the first place we want to look is related to, I'm going to call this example 1, is related to this function, f of x equals x squared minus 4 over x minus 2. Now, looking at this function, you might already notice a place that is a potential issue. If you haven't looked at it for real, go ahead and actually look at the function and see, can you see a place that might be an issue? Okay, because our first place that we always want to make sure to check is our denominators. Check for denominator, and then specifically where the denominator equals 0. Because we know that's an issue, right? We can't have a denominator equaling 0. Let me zoom in on that. I got a little small. Okay. We know we can't have a denominator equaling 0. And so in this case, if I were to figure out, well, what would make x minus 2 equal 0, the answer would be 2. Right? So we would say f of x is discontinuous at x equals 2. Now when it comes to discussing continuity, we want to make sure we answer the question. So say that the function is in fact discontinuous or is continuous, as the case may be. But the function is in fact discontinuous. We want to make sure we say where it is discontinuous, and then we also need why it is discontinuous. Which of my three conditions did I break here? And so that's why, again, you need to know your three conditions. Well, in this case, which one did I break? I broke the first one. I broke the fact that the point has to exist. Okay. In this case, if I plug in 2, I don't get a number. I don't have a point. I have a 0 in the denominator. So my issue here, f of x is continuous at x equals 2 because f of 2 does not exist. Okay. Okay, second place we want to check is related to both of these examples. So the first example is f of x equals, and it's a piecewise, x squared when x is greater than or equal to 3, and 2x when x is less than 3. Okay, I'm going to leave some space here so I can put in some work. Example 3 is also going to be a piecewise. Example 3 is going to be x cubed when x is less than 3, 9x when x is greater than 3, and 12 when x equals 3. Because the second place we want to check, besides where the denominator equals 0, relates to piecewise functions. And that second spot is the break in the piecewise. So right here we broke at 3. So we're going to check 3. Here, this function, we also broke at 3, and so we're going to check 3. So check the breaks in piecewise functions. Okay, so in checking the breaks, again, you gotta know your three conditions of continuity. Okay, first condition, I gotta have a point. And so as I look at example 2 here, if I'm checking 3, I need to see, do I have an f of 3? Now, starting from day 1, if you are checking something related to continuity, make sure it's on your paper. So if you noticed, I've written f of 3 equals. I'm not doing it all in my head. I'm not even just writing a number. I'm labeling it. I'm calling it f of 3. Okay, because it's going to pay off in the long run with where we are headed. And so make sure, starting from day 1, train yourself now to do it so that you don't have to retrain yourself later on. So since I'm thinking about the point, and I'm going to be checking the point, I'm going to write that point. So f of 3 is where the function is equal. So that's this top function here, this x squared. So f of 3 would be 3 squared, or 9. So first condition's met. That's not the issue. Second condition is that the limit has to exist. Okay? The limit has to exist. So we're going to go ahead and check that. Do I have a limit as x approaches 3 of this function? Like we talked about on Monday. The only way I can have a two-sided limit for a piecewise at the break would be if the left, or the limit from the left, was the same as the limit from the right. And so that's what I'm going to now check, are these the same? Because if they are, I've got a limit, and so my second condition would be met. So from the left would be this bottom function. So from the left is 6. From the right is this top function, which is 9. And so do I have an overall limit? I do not. 6 from the left, 9 from the right, they do not agree. And so I'm going to go ahead and now discuss the continuity. First of all, I'm going to say that the function is discontinuous. I'm going to say where it's discontinuous, at x equals 3, and I'm going to say why. So which condition did I break? I broke the second condition. I had a point existed. I did not have a limit that existed. Limit exists. Okay. So that's what I'm going to say. Because second condition, the limit as x approaches c in this case is 3 of my function, does not exist since. Because why does it not exist? Remember, we always want to support that does not exist. Since the limit as x approaches 3 from the left is not equal to the limit as x approaches 3 from the right. AKA does not agree, right? From the left, from the right are two different values. And here you go. So evaluating 3, again, we're checking the break in our piecewise function, which is 3 here. So condition 1, do I have a point? Well, yes, I do. At x equals 3, my function is 12. Condition 2, do I have a limit? Well, the only way to have a limit as x approaches 3 is if the left and the right are equivalent. So we need to find those. Well, my limit as x approaches 3 from the left is this top function. So it's 3 cubed, x cubed, which is 27. 3 from the right is this middle function, 9 times 3, which is 27. So I do have an overall limit, so condition 2 is met, but condition 3. Condition 3, I've said the point exists, I've said the limit exists, but the third one is that the limit has to equal the point. Limit as x approaches c of f of x equals f of c. And I run into an issue there because my limit is 27, my point is 12. So there's my issue. So again, one more time, f of x, we're going to answer the question. This is discontinuous. Where it's discontinuous, at x equals 3, and why it's discontinuous. Which point did, or which criteria did we break? And in this case, it's the third one, that the limit as x approaches 3 of f of x does not equal f of 3. I do want to highlight one more time, notice, okay? I've put everything down, everything we've checked. It's been labeled and articulated what that number is. That supports this reasoning in terms of the AP test. It's not going to be enough to have this if it was a free response question if you do not have work to support your statements. So train yourself now. Okay, my recommendation, I'm going to go ahead and put another function up here, but my recommendation, we're going to do 2 more, would be to pause the video after I put up each example. So I'm going to put up example 4 here, then pause the video, try it on your own, and then start the video again when either you get stuck or if you have an answer, so that you can either check your answer or you can get unstuck, whatever the case may be. But it's your choice. That would just be my recommendation. Okay, example 4. Let's do this function, f of x equals, it's a piecewise, x squared minus 4 when x is greater than 1, x minus 4 when x is less than 1, and negative 2x minus 1 when x equals 1. Okay, give this one a shot. Okay. Evaluating, point first, do I have an f of 1? Again, we're checking 1 because that's the break in the piecewise. Do I have a 1? Yes, I do. X equals 1 is negative 2x minus 1, or in this case, negative 2 times 1 minus 1, which is negative 3. Condition 2, do I have a limit? Which means I need to know left and right. Okay, well, 1 from the left is the middle function, x minus 4, or 1 minus 4, which is negative 3. From the right, top function, x squared minus 4, or 1 squared minus 4, which is negative 3. So I do have an overall limit. And condition 3, my point is negative 3, my limit is negative 3, so my point does equal my limit. So it's continuous. All 3 conditions are met. But now careful, because we can't just say f of x is continuous. We have to state why. We need, if we're discussing the continuity, we need to articulate each piece that we've evaluated because f of 1 exists, because the limit as x approaches 1 of f of x exists, and because the limit is equal to the point. And then one last time. It is not okay to say these pieces if you have not actually evaluated what f of 1 is. Because otherwise, for all the person reading your work knows, you've just said f of 1 exists because you feel like it. Right? We need to show that we know f of 1 exists by stating what f of 1 is. We need to show the limit exists by stating what the limit exists. So you have to show your thought process. Okay? One more. Example 5 is going to be f of x equals x plus 2 all over x squared plus 5x plus 6. Give this one a shot. Okay. So we're checking denominators in this case, right? This isn't a break in a piecewise one. This is a denominator equals 0. So we're trying to figure out what makes x squared plus 5x plus 6 equal 0. Well, my recommendation would be to factor that. You also could theoretically do quadratic formula, but it's a fairly easy factor. Will probably end up saving you time. So we're looking for two things that multiply to 6 and add to 5, so that would be x plus 3 and x plus 2. Which means I have two discontinuities. I have one at -2 and one at -3. Both are discontinuities. Now, someone in one of my periods asked about the fact that this could simplify. Does that change anything? No, -2 is still a discontinuity. It's still a place that would make this function, which is in the denominator, equal 0. What you're looking at here is a special type of discontinuity, which we'll look at in the next section. Okay, but we do have two discontinuities. So f of x is discontinuous at x equals -2 and -3. So stated that it's discontinuous, stated where, and then why. So you have to articulate which criteria did I break. In this case, it's the first one. The point doesn't exist. F of -2 and f of -3 do not exist.